So you're sitting at your desk on a cheery Friday morning, and your phone rings. You pick it up and answer, "Hello." The person on the other end says, "Hey, this is John over in the sales department. How you doing?" You say, "Good." And he goes, "Hey, I'm having problems. My computer, I can't do anything. The email doesn't work. The internet doesn't work. I don't know what to do. But I do know that in the lower right hand corner, by the clock in Windows, it has this little picture of the computer with an X over it. I think that means something's bad. So stop right there. Paused in the Friday. What goes through your mind as somebody describes to you that in Windows there's a little computer with an X over it in the lower right hand corner by the clock? Well, you may be thinking, oh, it must be network disconnected. It could be a port shut down. It could be a bad network card. There's a lot of things that should immediately shoot through your mind as you get more and more experienced in the Cisco world. And that's what I hope to give you as you walk through this video is just a switch troubleshooting thought process, how to think through problems as they come up. I'll then show you from my experience some common troubleshooting areas for the switch network that you may run across. Finally, the layer 2 world, the data link layer, switches are one of the softest, squishiest areas for security in the network world today. Now that is changing because there's been so much focus on firewalls and internet security that a lot of people have left switches behind. But as I mentioned, that is changing, and I want to show you some of the best practice from Cisco security recommendations for your switch network. When troubleshooting a switch network, the number one thing that can help you is to be familiar with that network. And you can partner that with the number 2 on the screen. Absolutely have an accurate network diagram. Those two things combined together will give you 90% of your troubleshooting. For example, you've seen just going through this series, the network diagram we've been using has evolved. It's a living diagram. As we add trunks to the network, we show lines connecting, we label them trunks. As we add VLANs to the network, we show what ports are in the VLANs. We show WAN links, we show IP addresses. In a Cisco admin's life, the network diagram is the lifeline of the network. If you let that go, then troubleshooting becomes just a nightmare, no matter what. So troubleshooting switch networks, thankfully, with those two things in place, with familiarity, that's a tough one to say, and an accurate network diagram, it shouldn't be too bad. There's not too much that can go wrong at layer 2. Now, don't take that to say that there's nothing bad that can happen at layer 2. There's all kinds of crazy stuff that can go on. But if you are familiar and have an accurate network diagram, you're 90% of the way there. Once those two pieces are in place, whenever an issue comes up, you need to, I guess, learn to work logically. And this is the best way I can say it is this is something that only comes with experience. I know we're talking at the CCNA level, but as you sit in network environments, and you will get experience as you get your CCNA, as you move into more and more network realms, you'll have experience with just common things that come up. And you'll be able to work logically from the bottom up. And what I mean by that is with the OSI model. Now, the reason I hesitate to say use the OSI model for troubleshooting is because sometimes it doesn't make sense. For example, somebody is saying, "Hey, I can get to these websites, but I can't access the server. I don't know. Can you help me out?" I mean, step one of that isn't to go, "Well, let's think. Is your network cable connected? Is there a break in the line? Is it, insert professional voice man there?" And, I don't know where that came from. So you don't think that. You think, okay, they're surfing the net. They're not able to get to that server. Okay, maybe there's some routing issues between the VLANs. Maybe there's some security between the VLANs that's blocking that person from the server. So when you're working logically, you need to take the problem that's being described and then apply what you know about the network to be true. Meaning if they're able to surf the internet, that means they are physically connected. They're getting out of the network. NAT is working properly. All those kinds of things instantly come into your mind. But don't take that to say that nothing really happens at the physical layer. There are times where I'll be troubleshooting a problem for an hour and then, come to find out, oh, it's it's a button on the laptop that turned off the network card or something like that. It's just one of those kinds of issues. So working logically from the bottom up Combining the experience and the familiarity with your network is the best troubleshooting process for any network. I'm glad I talked about that thought process first, because I was just thinking I'm going to give you some common troubleshooting issues that you may run into and some of the solutions. This is not one of those lists to memorize and say, okay, if that happens, I do this. It needs to blend into that logic and that train of thought to think, oh, I've heard of something like that before. Let me check these general areas. So here are some of the common issues. First off, on the port. These are with the physical port themselves. Number one, cabling issues. It never hurts to just verify that things are connected right. Second, verify that speed and duplex are auto-negotiating correctly. As I mentioned in some of the previous videos, speed and duplex is set to auto by default, and it's got, a 90-95% success rate, so it's pretty good. But that means that you will occasionally have a duplex misnegotiation, if that's a word. It's never the speed. The speed always works out okay. It's the duplex. One side will be set to half, the other side will be full. And what will happen is you'll get very poor performance from that device because you're dropping tons of packets. Now, on some of the switches and some, I guess, devices that access the network a lot, high traffic devices, it will send so many errors to the switch will shut down the port, or technically put it into an error disable state. So if it does that, that's better in my opinion, because their port goes out and they'll call you right away, and you can go and go, oh, I see you've got a ton of errors, let's figure this out. So hard coding the speed and duplex on those ports is the best bet. Finally, check that the assigned VLAN has not been deleted. So here's the scenario. You've got a PC that's plugged into a switch, and it's assigned to VLAN 10. But VLAN 10 has been decommissioned, meaning the company is no longer going to be using VLAN 10 for their network. Well, you may think you moved all the devices out and then remove VLAN 10. And what will happen to this port is it becomes kind of a nothing port. It becomes lost, literally. The light on the front of the port is your best indicator because it will immediately turn amber. It will be an orange color. So you can just look at the port and go, oh, there's a problem, and do some show commands. If a computer is assigned to a port, or I should say a port is assigned to a VLAN, and that VLAN no longer exists, the port goes into this limbo state where it just can't access anything. It's not like it goes back to the default VLAN or anything. So you'll know if the VLAN is gone because the device that's attached cannot access anything. Now we move into the spanning tree issues. Spanning tree issues, if you have an issue, will be a major one. With spanning, well, I shouldn't say always, but most of the time it's going to be like network down, fire in the hole, people screaming, and all that kind of stuff. It's a major issue. I guess the thing that I can tell you that you'll be able to see if there's a spanning tree issues is if you walk into the IT room and look at the switches, they'll all be just blinking like mad. If you've worked in a network for a while, you'll get the general feel for just how things look when you walk into the IT room. You'll see some lights blinking here and there. Some lights are going to be green and solid and so on. But when you go into a network where there's a spanning tree issue, and I should say more specifically, a loop has occurred where there's looping packets, you'll know it because you'll walk into that IT room and it just looks like a Bon Jovi light show. It's just wow, everything's going crazy, and that should immediately trigger in your mind something is very wrong, as in probably a spanning tree issue. What's happening is all of your switches will be pegged at 90 to 100% processor utilization. All of the PCs in the network will probably be down, although some may get some access, but very slowly because everything is so saturated. So to solve the immediate issue, grab your network diagram, remember that familiarity, and disconnect your redundant links. If a loop has occurred, that means spanning tree has broken down somewhere in the network. Find the redundancy and start disconnecting it. That will eliminate the immediate issue and at least get the network back and operational. Sure, redundancy isn't in place, but that's a side note. We don't need redundancy if the network's down. So from there, ensure all links are reflected on a network diagram. There is plenty of times that's happened to me where people just start daisy chaining hubs to another hub and to another hub and so on. Now, we don't get too deep in spanning tree in the CCNA level, but Spanning tree has an effective radius, meaning distance, of about 5 devices. So when you have a switch in your network, if you plug another switch into it and daisy chain another switch and daisy chain another switch, you know what I mean, this daisy chaining effect? Well, you can get about 5 away before spanning tree just starts breaking down. So somewhere around here, if you accidentally connect something like that, spanning tree won't be able to detect a loop and chaos breaks out. There's actually, I read this, oh, I wish I could remember what it was. There's this great white paper about a hospital. It's literally a Cisco hero story where there's this hospital where this exact system occurred, where they just, the network kept growing and somebody just not even thinking, plugged a switch in and plugged in another computer, and the entire hospital network went down. Now, when you're talking hospitals, you're talking life support systems. You're talking doctor notification systems. I mean, that's a network right there where people are depending, literally lives depend on the network. And Cisco got the call that the whole hospital had gone down. This white paper, I gotta find it for you. Hang on. I gotta write this down. I'm opening a little notepad document over here. Find hospital white paper. It's a great read. I'm telling you, because I'll give you the climax of the story. Cisco literally throws a bunch of CCIEs on a plane from San Jose, flies them out to this hospital, within it's some goofy amount of time, like 5 hours. They completely gut out the entire hospital network and put in all new Cisco equipment. I mean, just they're not even troubleshooting the problem. They're just gutting the thing and putting new Cisco gear in to bring the network back online because lives are dependent on this. And so anyway, it ends up being that the whole story is that it was a spanning tree issue that took the hospital down. So what was I talking about? Oh, here we go. So links are reflected on the network diagram. Make sure the root bridge. That's how I got on that story. There's a lot of times where people will start daisy chaining things and network diagrams never get updated. That's my point in telling you that is a lot of times employees under a desk. Oh, let me hook you up here, Fred, and they just daisy chain a switch, not knowing of the ramifications. So again, port security is big on that one. We'll talk about that later. All right. Ensure root bridge selection is appropriate, meaning find the core switch of your network and elect that as the root bridge. Make sure all switches are running rapid spanning tree protocol if possible, meaning if you have a fairly modern network where all the switches are newer, rapid spanning tree will recover much faster. All right, enough on spanning tree. VLAN and trunking issues. VLAN issues, number one, watch out for native VLAN mismatch. Now, again, the native VLAN is what a trunk port is assigned to if it's not trunking. It was for if you had a hub in the middle of two switches. So if this is a trunk port, the native VLAN on each of these should be the same. By default on Cisco switches, the native VLAN is 1. If you have a native VLAN mismatch, the switch will start reporting it on the screen. It'll say, hey, native VLAN mismatch detected. And that would be maybe this one is VLAN 10 and this is VLAN 1. What happens if you have a native VLAN mismatch is the VLANs will bleed together, meaning traffic from VLAN 1 and broadcasts in VLAN 1 will bleed into VLAN 10, and VLAN 10 broadcasts will bleed into VLAN 1. You can have issues like IP addresses from the wrong subnet being assigned because DHCP requests end up flying to the wrong VLAN. So just make sure that on your trunk ports, the native VLAN is set to be the same. If you need more info on the native VLAN, it's back into the VLAN nuggets. That's where we talked about that originally. So I don't want to rehash that whole thing here. Hardcode trunk ports to on. You might remember that by default, every port of a Cisco switch is set to dynamically negotiate, meaning if a computer plugs in, it becomes an access port. If another switch is detected, it becomes a trunk port. That's not good for security and just management purposes, so just hard code things. Hard code all your trunk ports to on the ones you want to be trunks. Verify IP address assignments in a VLAN. Make sure that the VLAN subnet is the same subnet that all the PCs are ending up with. And use ping and trace route to diagnose routing issues. Those are your best friends when trying to figure out what's wrong with maybe your router on a stick that gets you off the VLAN. Lastly, VTP issues, VLAN trunking protocol. Number one, Verify your trunks. VTP is the VLAN trunking protocol. It's used to replicate VLANs. And I mentioned it when we were talking about it before. VTP is not a trunking protocol, even though it's in the name. It just replicates. But the reason it got that name is because VTP only works over trunk links. So verify that you have trunks. Second, verify all your VTP info. Make sure the domain name and the password and version numbers and VTP modes. You might remember server, client, or transparent mode for VTP. Verify that all those things line up. And last but not least, you don't find this in many Cisco documentations, but to completely flush all VLAN information off a switch, you want to go into privilege mode and type in delete flash VLAN.dat. All the VLAN information is stored in that file. You will never see VLAN information in the running config. You do a show run, you won't see any VTP, nothing. It's all stored in VLAN.dat. It's kept separate. So if you want to truly flush a switch and just try again, delete that file and reboot. That will clear out all the VLAN information. Now let's take a turn and look at switch security. Actually, before we do, I want to bring up that hospital white paper I promised I'd find. I sort of found it. I can't find the original paper itself. There was a PDF, and if you find that, that'd be awesome if you could email me. But right on here on Google, I want you to go to Google and type in Cisco Hospital White Paper Spanning Tree. It's a strange string, but that'll find it. These first two links are the same article. It's a shorter version of the original full article, which is it's called All Systems Down. It's very well written. It's almost like a suspense novel. They essentially walk through how the hospital network failed and the 4 days that it took to get it up and running. And actually, I read through the article again. I couldn't stop myself. And there was one thing I just misspoke on the previous slide. The distance that spanning tree can go is 7 switches, not 5. I said 5. So they actually went beyond 7 switches at this network and multiple links. So it blew everybody's mind. All right. With that, let's turn back to switch security. Most of the focus in networks today, and I think I mentioned this at the beginning of this video, is on the network perimeter. Just about every article and magazine is all talking about internet security and how you need to protect your internal network from the internet. So everybody focuses their eyes right here on this boundary between the internet and the internal switched world. Now, the problem with that is, first off, it's not a problem. You definitely need internet security, but it leaves the inside of your network like a squishy Oreo center. If somebody gets in, then they just have fluff to cut through. There's no security there to stop them. Now, thankfully, wireless has actually added a lot of eyes to the internal network because wireless broadcasts your internal network to the rest of the world. So we've had to increase the security. So here is the security checklist that Cisco recommends you go through. Number 1 is physical security. If somebody can get to your switch physically, they can do a lot of damage very quickly. As a matter of fact, I'm not too sure how many of you know this, but on a Cisco stackable switch, and when I say stackable, I mean just the normal small switches you buy for networks, not the big chassis ones like the 6500 series, but just the normal switch. If you hold the button on the front of the switch, it's the little mode button, for 10 seconds or more, the switch will automatically erase all its configuration and go back to the factory default. Now you can turn that feature off, but most people don't even know that feature exists. So just about every switch that I've seen leaves it on. So if somebody busts into the IT room or just gets to the switch, we'll not make it so dramatic, and holds one of those buttons for 10 seconds, they can completely nuke the config. So physical security is a must. Second is set passwords and logon banners. We talked about that already on console ports, on VTY lines, enable secret. Third is disable the web server. On older iOS versions, the web server feature is enabled by default, and even on some of the newer versions. To disable it, go into global config mode and type in no IP HTTP server. That shuts it off. You can also type in no IP HTTP secure Oh, this one doesn't have it. There's actually on other iOS versions the secure server, which is the HTTPS version. That one's not on by default, but if you want to shut down both web servers, that's how you do it. The web interface is most of the time not useful anyway. Now, some of the newer switches have a full-blown graphic interface that show the switch, and you can actually point and click. It's very pretty, but most of the older ones don't have that. And when I say older, I mean a year or two old. So they'll just have a text window where you can start executing commands, and there are some vulnerabilities that have been found in that web server. So just turning it off is the best bet. Limit remote access subnets. And we'll talk about access lists in a moment, but what that means is don't let people telnet into the switch or SSH into the switch that don't belong there. If somebody can telnet to the IP address of the switch, they can just randomly begin trying passwords to break in. By using an access list, you can say only this IP address or only this subnet of addresses is allowed to telnet to the switch or SSH to the switch. So when possible, lock it down that way. Next, use SSH rather than Telnet. I will fully admit to you that SSH is more inconvenient, not only because it's a pain to set up, but also because Telnet is just about embedded in every operating system. You go to Windows and open a command prompt and you've got Telnet. You don't have to download PuTTY or Terraterm in order to get SSH capabilities. So Telnet is a little more inconvenient, but SSH is far more secure. Next, configure logging. Most people will just leave logging at default, which is on the console. And what that means is, you see right there, I'm connected to the console port. Every time you do something, it will report something to the screen. Or anytime an interface goes up or shuts down, it will report to you this interface is up or down, or, all the reporting is sent to the console port. Now, the best bet to track that is to go into global config mode and type in logging. I'll show you the simplest way, logging buffered, and then type in a memory level. So we'll just say 64,000. What that does is allocate 64,000 bytes, which is a decent amount. It's not a huge amount. I'd say it will hold maybe, depending on the type of network, but maybe 3, 4, 5 days of logging information on what's happening on the switch to the memory. So you can then go back and type in show log, and it will show you all of, well, see, you can see right there, 64,000 bytes. No messages have been generated yet. Here, let me do this. Let's generate some messages. I'll do a shutdown, a no shutdown. There we go. It's back up. Interface 024 shutdown, no shutdown. Just, get some messages going on here. There we go. Now I'm going to go back and do a show log. Full command is show logging. And you can see all of the stuff that happened is saved in that memory buffer. So I can go back and see what's going on. Now, of course, there's going to be more interesting stuff than interfaces going up and going down on a full production switch, but that is setting up logging. The other way that you can log is you can type in logging from global config mode and type in the IP address of a remote host. Now, that remote host could be just a PC running. I'll show you a handy program of the day. It is let's see if I can remember. Let me open a new window here. It's Kiwi syslog, www.kiwisyslog.com. Right there. Kiwi syslog. Now, if you go here, you'll see right here a freeware I can't even say it. A freeware syslog daemon. And when you click on that, you can download this for your PC. It is just a pretty nice logging system that will receive these messages, and you can put them in a table format. You can search through them. You can find them. They're in a buffer and all that kind of stuff. So that you install that and run it on a PC, and then you go to your command line and point your switch to the PC running the Kiwi syslog, and that will configure logging. Now, down at the bottom, we see limit CDP reach when possible. Limit where CDP is running. Now, there's two ways to do that. Go into global config mode and type in no CDP followed by run, which turns off CDP on the switch as a whole, thus the global config mode. That will disable CDP everywhere, and you will no longer be able to see the switch using the Cisco Discovery Protocol. You can also go under each interface if you'd rather do it on an interface by interface basis and type in no CDP enable. Now, the reason that is a good security practice is because CDP is something being originated by the switch, meaning the switch is going to send out CDP broadcasts once every 60 seconds out every single port that it's connected to. Somebody can just open up a packet sniffer on their computer and receive the CDP information, which tells them the name of the switch, the IP address of the switch, the iOS version it's running, all the CDP information we talked about was that in this series? Maybe even the previous series, that you can see on all the different devices. Just in case it was the previous series, let me just make sure. I'll do a show CDP neighbors. That should help refresh your memory. Show CDP neighbors detail, seeing what is connected to this device via CDP. So a lot of times it's good to turn that off. Now, you notice I have when possible. That's because a lot of the new Cisco equipment, like their IP phones, need CDP to operate correctly, or to operate efficiently, I should say. So it may not be possible to turn off CDP. Last but not least, use BPDU guard on port fast ports. Now you might remember port fast was the utility that essentially disabled spanning tree. So if you plug in a PC, it immediately goes online rather than waiting for the 30 seconds that spanning tree takes to make a port go active. Now it's always best to couple that with BPDU guard. Let me first show you the syntax, then I'll explain what that is. You go under your interface that is enabled for port fast, and you type in spanning tree followed by BPDU guard. What it says is don't accept BPDUs on this interface. Now, if you think back, if you're thinking BPDUs, that sounds familiar. It's from the spanning tree videos earlier in the series. Spanning tree uses BPDUs to announce itself. So what BPDU guard does is if you have a switch enabled for port fast and you connect another switch, well, that violates the port fast agreement. Port fast is only for PCs. So if a BPDU comes into that port, the switch realizes that another switch has been attached to that port, and it will immediately shut down this interface. BPDU guard will take it down. So that's very handy to help prevent a lot of the loops. It also helps prevent this kind of scenario. Somebody plugs in a hub under their cubicle and daisy chains to another port in another cubicle, which links back to the switch. Well, the switch will send out a BPDU out this port, go through the hub, through another hub, and then it will come back into itself. BPDU guard, it detects that and will shut down both of those interfaces because it detects the loop in process. So that is a great one. I want to make sure you don't confuse that with BPDU filter. BPDU filter is a dangerous one. It says don't accept, or I should say don't send or receive BPDUs on this interface. The reason that's dangerous is it will ignore BPDUs coming on that port. It doesn't shut the port down. So somebody could set something like this up with BPDU filter turned on, and the switch would never detect the loop, and that's what would cause one of those hospital incidents that take the network down. That wraps up the troubleshooting and security practices for our switch network. And that wraps up switches for this entire video series. We're not going to talk about switches anymore. It's going to be all router concepts from here on out. So let's recap. We saw the switch general troubleshooting process, looking at the OSI model as a guide, using a familiarization with your network and a logical network diagram to help you out. We then saw a lot of the common troubleshooting areas for our switch network, things like the port issues and spanning tree issues. And we saw securing the switch network, the best practices that Cisco recommends to lock down the inside of your network a little tighter than leaving it as is, which is wide open. I hope this has been informative for you, and I'd like to thank you for viewing.